All right, this is our exit ticket for confidence interval. So a soft drink bottler vendor claims that its bottles have a mean internal strength of 157 psi. The standard deviation is known as 3 psi. So, okay, we have a standard deviation of 3 psi. However, the distribution of strengths is highly skewed to the right. The bottler took a random sample of 45 bottles out of the 4,000 produced in 1 hour. So N is 45. From the sample, the bottler calculated a mean strength of 156. So this came from the sample, which means this is our sample mean, which this is our X bar. So our X bar is 156. And it says, define the parameter of interest. All right. Well, what we're interested in is the mean strength of the bottles. So let mu equal, we know the sample mean, so we're curious about the population mean. Let mu equal the true population mean bottle strength. Not really one of the internal strength, but we'll just call it bottle strength, and that'll be good enough. Check the conditions. All right. First off, we had to have a random sample. They said, oh, random sample of 45. So first condition, random sample of 45, and we'll put a check mark by it. The N is less than 10% condition. Well, N equals 45, and 45 times 10 is less than, is less than 4,000. So we can check that because 45 times 10, and you could have multiplied it out if you wanted to. 45 times 10 is 450. Well, 450 is less than 4,000. So we're good there. And then we need to check the normality condition. Did they tell us it was normal? No, they said it was skewed. Uh-oh. Oh, but our sample size is 45. So N equals 45, and that's greater than or equal to 30. Normal by central limit theorem. All right. Says calculate a 97% interval for the above scenario. All right. So our formula is going to be X bar plus or minus Z star, the standard deviation divided by the square root of N. So let's plug in what we have. Well, we know we have the 156. We don't have Z star yet, so we'll have to come back to that. But we also have the standard deviation of 3, and we have the square root of 45, which is our sample size. So what I am missing still is my Z star. Well, they want a 97% interval. So that means I'm going to have to go to my inverse norm and do a 0.97. So let's do that. So second vars, inverse norm, 0.97. It's a Z score, so our mean is 0. We want to make sure we're centered. And we end up getting 2.1700. So this is 2.170. All right, so now we have everything, and we can go ahead and calculate our interval. And to do that, we're going to go stat test number 7 Z interval. And our standard deviation happens to be 3. Our X bar is 156. Our sample size was 45. And we wanted a 97% interval. And we end up getting 155.03 to 156.97. So that's our interval, 155.03 to 156.97. Well, that means I'm 97% confident that the true population mean lies within this interval. All right? No lower than 155, no higher than 156.97. So it says at the 97% confidence level. Is the bottler's claim of 157 reasonable? Well, I look at that, and 157 is not in the interval. So no, the claim is not reasonable because 157 is not in the interval. All right, that takes care of number one. So number two, the amount of water consumed per day by Montana residents is normally distributed. Okay, that's important. They told us it's normal. With a mean of 125. So mean is 125 and a standard deviation of 10. So this is my population mean and this is my standard deviation. The city of Bozeman claims that the average water consumed in Bozeman is less than the state. A simple random sample of 11 residents. Ooh, we got a sample size. In Bozeman found an average of 120 gallons consumed per residence. So my X bar is 120.3. Define the parameter of interest. Well, we're interested in how much water they drink in Bozeman. And it's always going to be let mu equal the true population mean amount of water consumed, in this case, in Bozeman. We're not talking about the entire state. Check the conditions. First condition has to be a random sample. Well, is it? A simple random sample. Okay, one random sample. Oops. Random sample where n equaled 11. So check. 2, we need to know about the n is less than 10%. Well, my sample size was 11, so n equals 11. 11 times 10 is 110, and that's less than the population. Now, we don't know the population size, but we're going to assume that it's less than 110. I mean, much greater than 110. The 110 is less than 10%. 3, normality condition. In this case, normal given. And by the way, I should have written given on this one too. All right, it says calculate a 92% confidence interval for the above scenario. Well, let's go ahead and start by writing my formula. X bar plus or minus Z star, the standard deviation divided by the square root of n. And we'll start plugging in what we know. We know X bar is 120.3, 120.3 plus or minus. We don't have Z star, but we do have our standard deviation of 10, and we have a sample size of 11. So we have everything plugged in we know, but we don't know Z star. But they want us to calculate that. It's giving us a percent. So we can go to inverse norm, 0.92, and we're going to get a lower and an upper. So inverse norm, 0.92, mean of 0, standard deviation of 1. And the reason we know that is because it's a z-score, because we're looking for a z-star, so we're looking for a z-score. So second vars, inverse norm, 0.92, mean of 0, centered. And we end up getting a z-score of about 1.7506. All right, now that we have all that information, we're ready to go ahead and calculate our interval. So stat over to test, drop down to number 7, which is our z interval. And In this case, we have a standard deviation of 10. We have an X bar of 120.3. We have a sample size of 11. And they wanted a 92% confidence level, 0.92. And when we do that, we end up getting 115.02 and 125.8. 115.02 and 125.58. So this is my lower and this is my upper. Now, interesting, this contains the 125. All right, so at the confidence, 92% confidence level, can we say that Bozeman uses less than 125 gallons? And it's like, no, we cannot, because the interval contains 125. All right, this is Mr. Spence and appreciate you watching. Hope to see you on the next one.